The next one is soil water. We have already discussed in the first class is, if this is a soil, okay, for example, around 45% will be mineral matter, and the 5% is organic matter, and the 25% will be soil water, and the another 25% will be soil air. This 25% is soil water and this 25% is soil air. This is what it is given here. The 45% of minerals, 25% of air, 25% of water, and 5% of organic matter. There are different kinds of soil water. We majorly divide this soil water there are two classifications. That is the physical classification and the biological classification of soil water. Biological classification, physical classification. In physical classification, we can see these three: the gravitational water, capillary water, and the hygroscopic water. We will discuss these three terms here. In case of biological water, biological means we are considering plant here. That's why how it is helping plant. This water, how it is helping plant. That's why it is called biological classification. Here again it is divided into three types: available water, unavailable water, and the third one is superfluous water. Superfluous water. We will discuss these six terms here. So the first one is physical classification. Gravitational water, capillary water, and hygroscopic water. By the term gravitational water, you can assume that it is present in macropores, and this water flows or moves under the influence of gravity. That's why it is called gravitational water. It is present in macropores. It is also called as free water because it is not held by the, it is not held by the soil particles. It is not adhered to the soil particles. That's why it is free water. When there is a gravity, it flows. The next one is capillary water. It is mainly present in micropores, and this water is used by the plants. Because it is retained by soil by surface tension. And it is useful for the plant. I forgot to mention one more word here. This gravitational water present at the potential of, means at which tension it is held at from 0 to 1/3 atmosphere pressure. At this potential we can see there is a gravitational water. In case of capillary water, it is held at 1/3 to 31 atmosphere pressure. And the plant root absorb this kind of water, that is capillary water. The third one is hygroscopic water. It is very tightly held. On the surface of the soil colloidal particle, that is called hygroscopic water. And the water is held at more than 31 atmospheric pressure. See, these are the We can see these three types of physical classification of soil water. One is gravitational water. It is held at 0 to 1 by 3 atmospheric pressure. And the capillary water, that is held at 1 by 3 to 31 atmosphere. And the third one is hygroscopic water. It is very tightly held. It is adhered to the soil particle. It is held at more than 31 atmospheric pressure. And this capillary water is available for the crop for use. And this gravitational water, it drains due to the gravity. Now we will move to the biological classification of soil water. There are three kinds: available water, unavailable water, and superfluous water. We will discuss by one chart here. See, for example, this is a 0 atmospheric pressure. This is 1 by 3. This is 15. This is 31. Okay. The hygroscopic water held at more than 31 atmospheric pressure, that is hygroscopic water. Hygroscopic water. It is held at more than 31 atmospheric pressure. And the capillary water is held at 1 by 3 to 31 atmospheric pressure, that is capillary water. And the 0 to 1 by 3 is, it's a gravitational water. These three we have already discussed. Again, in case of available water in the sense, it is available for the plant, for the growth. It is held between 1 by 3 to 15 atmospheric pressure. We can see this part. This part is available water. And unavailable water is more than 15 atmospheric pressure. Whatever we can see here is it is unavailable water. More than 31 15, more than 15. It is held at more than 15 atmospheric pressure. And the superfluous is less than one third. This is what the superfluous is. Superfluous water. These three are biological classification of water. These three are physical classification of water. You remember this diagram, will not be confused. And this is what is given here. You go through once. See, there are some terms here. We will see here. The halide is nothing but it's a total available water in the soil, that is called a halide. Crescite is available to the plant. The crescite is nothing but the water that is available to the plant. And the ecard is that the water that is not available to the plant is not ecard. You go through this diagram. We have already discussed this. At what tension, at what potential, different kinds of waters are available to the plant, and different kinds of soil water that is held at what temperature, tension, potential. There are some soil moisture constants. There are three constants. One is field capacity. One more is Wilting coefficient, and the third one is hygroscopic coefficient. See, when there is a rainfall, water from macropores drained due to the gravity, and after some period of time, for example 2 to 3 days, water in the microspores will be present. There will be water in the microspores. These microspores are still they are filled with some of the water in the micropores, and they are held at zero point 0.1 to zero point 0.3 atmospheric pressure. They are held at the capillary pores. That is what is known as filled capacity. Means after there is a rain, after 2 to 3 days, soil is said to be at filled capacity because the water is present in micropores, that is capillary pores, that is used by the plants. Wilting coefficient, it is also called as permanent wilting point. Water at wilting coefficient is held at a force of 15 atmosphere. Hygroscopic coefficient. Hygroscopic coefficient is the maximum amount of water, hygroscopic water absorbed by the 100 gram of dry soil under standard conditions of humidity. If there is a 100 gram of soil, how much hygroscopic water absorbed by this 100 gram of dry soil under the standard conditions of humidity, that is 50% of RH and at 15 degrees Celsius. Next we will see the entry of water into the soil. There are different terms here. You go through once. Anyway, we will discuss briefly here. Entry of soil. There are different kinds of flow within the soil. When there is a precipitation, water gets infiltration. There is a percolation. There is a drainage. There is a seepage. We will discuss these terms briefly. The first one is infiltration. Whenever there is a rainfall, the water moves into the surface soil. When there is a rainfall here, water moves into the soil, that is infiltration. When the water gets into the deep soil, that is called percolation. See here, infiltration refers to downward entry. It's a downward entry or the movement of soil into the soil surface. That's what the infiltration means. And it occurs in unsaturated soil because this soil is unsaturated. Once the rain falls, it gets into the soil, water gets into the soil, unsaturated soil. It occurs in unsaturated soil. That's what the infiltration means. You go through once here. The next one is a percolation. It occurs in saturated soil. It's a movement of water through column of soil. First one is infiltration. The next one is percolation. See, the percolation is nothing but it's a movement of water deep into the soil layers, deep into the soil columns, soil layers. It goes deep. It occurs in saturated soil. Then the next one is permeability. It's a ease of movement. If the soil ease of movement, it is an ease of movement. Soil can be partially permeable, or it is fully permeable, semi permeable. We can also say it is a semi permeable. So it is a relative ease of movement. The next one is drainage. Drainage is nothing but it's a removal of excess water. Removal of excess water. The next one is seepage. Seepage is nothing but it's a horizontal flow of water. It's on horizontal. What we have seen above is all they are vertically flowing within the soil surface. The seepage is nothing but it's a horizontal flow of soil. You can see here the water is flowing horizontally. I have given some differentiation between infiltration and the percolation. Difference between infiltration and percolation. Infiltration is nothing but the process by which water on the ground surface enters into the soil. It occurs in unsaturated soil. Percolation is nothing but it's a slow movement of water through pores or the permeable rock. It's a downward movement of the water into soil. It is also a downward movement of water into the soil. It occurs faster because it occurs in unsaturated soil. It occurs slowly because the soil here is saturated one. So and then the next there are two more physical properties here: soil air and the soil temperature. We have already known that there are 25% of soil is of soil air, and the 25% of soil is of water. 45% is of mineral content, and the 5% is of organic content, organic matter. And the soil air contains 10 times more carbon dioxide than the that of air. You remember this fact? Soil air contains 10 times more carbon dioxide than that of air. You remember this law, Fick's law related to soil air, and there is one more law, that is Fourier law, that is related to soil temperature. Do not go deep into these laws. The Fick's law related to soil air. Fourier's law related to soil temperature. Soil temperature is nothing but the soil, soil heat is mainly transferred through conduction. Soil heat is mainly transferred through conduction. There are three types of heat transfer. There are three types of heat transfer they are one is conduction here. Conduction is nothing but it's a direct transfer of heat energy. It's a direct transfer of heat energy from one particle to another particle. There is a movement of heat. One more is convection. Convection is nothing but it's a movement of heat. By actual movement of matter. Here, the movement of matter itself takes place. The conduction here, it's a direct transfer of heat energy. It's a transfer of heat energy. Here, in case of convection, the matter moves from one place to another. For example, if there is a soil, if there is a lot of sun rays here, the water in the soil moves to the after getting heated, it moves to the atmosphere. So water particles moves here. That's what the convection is. In case of conduction, it's a movement of heat from one particle to another particle. Heat energy. And one more is radiation. Again, here is a sun. For example, it is a sun. Sun rays will be coming to the earth. In case of and this is called as the radiation. So these are the three types of heat transfer. So soil temperature, in soil mainly conduction happens. Sandy soil absorb more heat than the clay soil, and the soil temperature is stable below 80 centimeter of soil, because the soil heat cannot go there or sun rays cannot go there. So these are the physical properties of the soil. I hope you understood all the properties of the soil and the formation of the soil. And we will see some of the important topics in the next upcoming classes. Thank you for your patience. Thank you.